All right, here we go. Second part of the ionic bonding here, folks. This is where the first comedy video ended up, talking about crystal lattice, lattice energy, and formula unit. Crystal lattice is the three-dimensional arrangement of all the ions. There are different kinds. We're not going to worry about the specific kinds. Lattice energy is the amount of energy needed to break apart that crystal lattice, or the opposite of that is it is the amount of energy released when that crystal lattice comes together. And like we've had for several weeks now, we always want our ions to be the smallest numbers possible, and that is called the formula unit. So what does this strong attraction repulsion scenario do for us? It's going to define, or it's going to give us the general properties. There are exceptions, but the general properties for ionic compounds. Consequently, that means that ionic crystals or ionic compounds are almost always solids at room temperature, because those particles, they stick together, strong attractions. But they are very brittle, because when they get themselves together, they line up perfectly for the attractions to work. And if you bend them just slightly, you knock them out of alignment, you ruin the alignment, and you get into strong repulsions. So they don't bend, they just break. Let me give you an example. An ionic compound would be the glass in a window. Have you ever accidentally broken a window? Hit it with something not very flexible. Other properties of ionic compounds, because they stick together really well, they tend to be what? You think they're tough to boil and melt, or are they going to be real easy to get them to melt? Yeah, they're going to be tough. Green was a bad color. They're going to be tough to melt. They're going to be tough to boil. That means the temperatures will be pretty high. Because the particles are all held in place tightly in that crystal lattice, they do not conduct electricity worth a hoot. They are insulators. They are bad conductors. They are insulators. The last thing, luckily though, most of them do, many of them do dissolve in water. And so we say they are pretty soluble. They do dissolve in water. And that gives us, so your general properties of ionic compounds: solids at room temp, they are brittle, tough to get them to melt and or boil. They do not conduct electricity very well. Unless you dissolve them in water, then some of them become electrolytes. The fancy word, you think of your Gatorade, you think of your Powerade. When you sweat, you lose what? You lose electrolytes. Electrolytes are substances that will conduct electricity, but only when they are dissolved in water. Table salt, as a solid, no conduct. But dissolved in water, great conductor. It's just like a piece of copper wire when it's been dissolved in water. Now don't confuse an electrolyte with a battery. No, 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 no. A battery makes electrical charges. An electrolyte carries electrical charges. So obviously if you put salt in water and stir it, you will not get shocked when you put your hand in it, because it ain't making electrical charges. It would just carry it like a piece of wire. So we go back and look at our salt crystal here. It is pulled left, right, top, bottom, out, in. It's pulled in all 6 directions. It is held very, very strongly. Strong attractions in all directions. All 6 directions. But if you try and bend this, if you slide Greenie, if you slide him over 1 notch, and now suddenly he's on top of another green, what does that do? In fancy words, that would be bad. And you would be suddenly knocked out of strong attractions, and you would be into extremely strong repulsions in all directions. And so just some various numbers here, and I only put these up here to get you to reference water. You think of water. Water melts at 0, it boils at 100 degrees Celsius, but water is not ionic. Water is covalent. And while 100 degrees seems like a high temperature to us, compared to the ionic stuff, 100 degrees is nothing. It's very low.